Hello everybody and welcome back. In this video, I'm going to be showing you 10 Python shortcuts that you need to know. None of these shortcuts are advanced, they are simply Python language features that save you a few lines of code and a little bit of time. These things may exist in other programming languages, but most of them are specific to Python. And well, if you write in Python a fair amount, this is definitely something worth watching and shortcuts worth remembering. So with that said, the first thing that you need to know is actually the sponsor of this video. Thanks to Career Karma for sponsoring this video. Career Karma is a platform that helps connect learners like you to amazing boot camps and courses that prepare you for jobs in tech. I've worked with Career Karma in the past and share their mission of inspiring, motivating, and helping others get started with their tech careers. If you're looking to start your career in tech as a web developer, data scientist, UI, UX designer, whatever it may be, then Career Karma can help you in your journey and get you into some great boot camps. Boot camps are the fastest way to quickly switch to a tech career that affords a six-figure salary, work-from-home flexibility, and high job satisfaction. On the Career Karma app, you can join live audio rooms and speak to people like me. In fact, I just did a live audio room the other day and it was a great experience. To get started, download the Career Karma app from the App Store or click the link in the description where the first 1,000 of my subscribers will get exclusive access to a free coaching session with a Career Karma coach. Thanks again to Career Karma for sponsoring this video. All right, so let's go ahead and dive in. The first shortcut I have to show you is called f-strings. Now, f-strings only work in Python version 3.6 and above, but they simply allow you to embed Python expressions or variables inside of a string without having to use concatenation or string formatting or any other method you may use. So for example, let's say we have some variable and it is called name, it is equal to Tim. Let's say we then want to print out hello and then whatever the value of the name variable is to the screen. Well, a few ways we could do this would be the following. We could print something like hello, comma, name. That would work. We could print something like hello space plus name, and that would work. Or we could use an f-string, which just makes things a lot easier. An f-string is simply a lowercase or uppercase f followed by a string, either double quotes, single quotes, or triple quotes in either single or double quotation marks. And then inside of the f-string, you can simply write any Python expression or variable inside of curly braces, and it will be evaluated as a string. So if I print hello name like that, let's just remove this, we can see that this actually works. We get hello Tim. Now, the great thing is when you have complicated strings that are using variables or expressions, you can add stuff before and after the f-string, or sorry, before and after the expression. You can embed multiple expressions. So I can do something like name times 2, and then I get hello, Tim, Tim. I could even do some basic addition, maybe 2 plus 3 like that. I could write maybe a list inside of here, right? I could do something like 1, 2, 3, and then that gets displayed as a list. So there's a lot you can do with f-strings. Again, it's a lowercase or uppercase f, only works in Python version 3.6 or above, and in my opinion is a shortcut to create a string. Now, lastly, you also could do something like x is equal to, and then do that. You don't have to be printing the f-string. And then I could obviously print this string, so print x, and you get the same thing. All right, that is shortcut number 1. Let's move on to number 2. So moving on to shortcut number 2, I have for you unpacking. Now, unpacking is extremely useful, and essentially what this means, or what this allows you to do, is assign variables to all of the values inside of some type of collection in Python. So a collection in Python could be something like a list, like a dictionary, like a string. Those are all examples of collections. And well, what you can do is something like the following. So see here inside of tup, standing for tuple, I have 5 values, 1, 2, 3, 4, 5. Let's say I wanted to assign all of those values to variables. Well, I could do something like a equals tup at index 0, and then b equals tup at index 1, so on and so forth. But that's pretty repetitive, and I don't really want to write that. So instead, what I could do is a, comma b, comma c, comma d, comma e is equal to tup. And when I do that, Python knows to automatically assign a equal to 1, b equal to 2, c equal to 3, so on and so forth. And to prove this to you, I can just print them all out. So if I do this, you see we get 1, 2, 3, 4, 5. So you can do that with pretty much any collection. I can also do this with my list, so lst. Notice that works as well. I could do this with my string, so let's go ahead and do that. I get hello, well, all spaced out hello. I could do this with my dictionary, so let's change this to just be AB, and then DIC. Okay, AB like that. Notice this works. Notice when I do this with a dictionary, it gives me the keys. It does not give me the values. If I wanted the values, I would do, or sorry, items, I would do dic dot, actually not items, dot values. And then that's going to give me the values. And if I did items, you'll actually see what we get here. We will get tuples. So A1, B2, A is obviously the key, 1 is the value, B is the key, 2 is the value. So it works with that. And then a very common way or reason people use this is you have something like coordinates and you want to unpack them into X, Y. So you can see I have my chords here for 5, X, Y, and then I can go X, comma, Y. And well, there you go. I've unpacked this collection. That's pretty much it for how unpacking works. Pretty simple, but definitely very useful and saves you from having to write out a bunch of different variables on a bunch of different lines. You can simply unpack the collection in this fashion. One last thing to note is that if you have something like XYZ equals chords, you're going to get an error because it cannot unpack. There's not enough values here to unpack into these 3 variables. All right, let's move on to shortcut number 3. So I don't really have a proper name for this one, but I'm going to call it multiple assignment or variable swap. But essentially, this shortcut allows you to assign multiple variables on the same line. This is common in other programming languages, but I figured I'd show it here in Python. So for example, let's say I have a width and a height. I can define them like this, 400, 500. So rather than having to write 2 lines, width equals 400 and height equals 500, I can simply do it on 1 line. So that's great, but the more useful aspect of this feature is that I can actually swap the values of variables in 1 line as well. So in other programming languages, if you wanted to swap the value of width and height, what you would have to do is something like this. Temp is equal to width, width is equal to height, and height is equal to temp, because you need some way to store the value after you reassign this variable. Because once I assign width equal to height, I lose the value for width, and so I need to store it in this temporary variable. So instead of having to do that in Python, what you can simply do is say width and then comma height is equal to height comma width. And just to show you that I'm not lying here, I can print the width and the height. Let's delete all of this, and you should see that we get 500, 400 because we have swapped the width and the height. So that's it for this. You can obviously do this with multiple values as well. So even this inline swap, I could say width, comma height, comma X, and then I don't know, maybe make this like 5 or something. And well, that still works. All right, so with that said, let's move on to the next shortcut. All right, so moving on to one of the more useful and popular Python shortcuts, we have comprehensions. Now, a comprehension is a way to initialize or create some type of collection in Python in 1 line. So let me just show you with a list first, and then I'll show you with some other collections. So here we have a list, and I want to initialize this list with some values. Let's say I want to fill it with zeros. Maybe I want to fill it with 100 zeros. Well, I could write a for loop. I could say for I in range 100, and then say x dot append 0, but this is not the Pythonic way to do this. The Pythonic way to do it is the following: 0 for I in range 100. When you do this, it is going to put whatever is on the left of the for statement inside of the list, however many times this is running. So in this case, if I print out x now, we see we get a list filled with 100 zeros. Now, of course, I could use the value I here, so I for I in range 100. Now I get a list that goes up to 99 starting at 0. And if I wanted to get even more advanced, I could add an if statement here. So I for I in range 100, if I mod 2 is equal to 0. Now we're only going to get the even numbers plus 0 inside of here. I could add another for loop, so I could say for j in range 10, and then maybe I do the product of I times j. Now, if I do this, obviously I get a large list, but you can see where I'm going with this and how advanced you can really make this. Of course, you can do a nested list comprehension as well. I could do a list inside of here and say 0 for underscore in range 5 for underscore in range 5. This will create a 2-dimensional array for me. So here you can see now we have an array or a list inside of a list. If you're curious what the underscore is, you can simply use an underscore instead of a variable name if you're not going to actually use the variable or iterator for your for loop. And yeah, that's pretty much how you use or do a list comprehension. Now, of course, you don't only have to do a list comprehension. You could do this with a dictionary, a tuple, other data structures. I'll quickly show you. So what I'm actually going to do here is create something known as a generator. You don't have to know what that is, but that's why you'll see some weird output in a second. So I'm going to say I for I in, and let's just go with hello. And now notice I get a generator object. Don't worry about what that is, but if I convert this to a list, you can see that I get hello. So this does work with tuples as well. Or sorry, I could just convert this to a tuple, and then I get that in a tuple. Nice. Okay. Other than that, I could do this with a dictionary. So a useful thing we can do with the dictionary is say count all of the characters in a word. So let's say I have a word which is equal to hello, my name is Tim. I understand this isn't a word, but we can just change this to sentence. What I can do now is something like char colon and then sentence dot count char for char in the set of the sentence. This might seem a little bit complicated, but I'm getting all of the unique letters from the sentence. I'm looping through them. And then for every single one of those letters, I'm counting how many times they occur inside of the sentence. Not the most efficient way to do this, but this will give me the frequency of these characters in the sentence. So if I do this, now you can see I am getting that from this dictionary comprehension. All right, I'm going to end it there. You can do this with a few other collections as well. But let's move on to the next shortcut. The next shortcut I have for you is a simple one. This is object multiplication. This simply allows you to multiply objects in Python. When I say objects, I don't just mean numbers, I mean strings, lists, etc. So let me show you. So a very popular thing to do is to multiply a string. So let's say I have a string hello. Maybe I want to multiply this by 5. Well, you can guess what the result is going to be. Well, we get hello 5 times. So that's what I'm talking about here. Now, of course, you can multiply a list as well. So 1, 2, 3 times 5, I get 1, 2, 3, 5 times in the same list. We can multiply a nested list if we wanted to do that. 1, 2, 3, and then we get the nested list inside of the larger list. I could, of course, do this with a tuple as well. So let's just go 1, 2 times 5. Of course, you can make this a larger number. Now, if you try to do this with 2 tuples or something, you'll see that the few things I just showed you, lists, tuples, and strings, definitely are multipliable in Python. The next shortcut I have for you is very popular in most programming languages. In JavaScript, they have this. In other programming languages, they have this. And this is the ternary or inline operator / condition / if statement. So what I mean by this is the following. In Python, you can do something like this. X is equal to, and then I could say maybe 1 if 2 is greater than 3, else 0. And if I print the value of X, well, you're going to see we get what we would expect here. So you can put some type of condition. You put what you want to occur or what you want to be assigned to the variable on the left-hand side of the if statement, and then what you want to happen if this is not the case after the else. So whenever you do this, you do need an else. Notice if I go like here and I don't add an else, we get invalid syntax. You must have an else. Pretty straightforward. That's what it is. Now in JavaScript, the parallel here would be this. X is equal to 2 greater than 3 question mark 1 colon 0. So you're putting the condition first, then you're putting what occurs if this condition is true. Otherwise, you are putting what happens otherwise, right? If this condition is false. So pretty straightforward, but this can be useful if you want to not have to actually write the entire if statement. Obviously, if I wanted to write this out, I would have to do something like if 2 is greater than 3, X equals 1, else colon X equals 0. So you can see this saves you quite a few lines of code and just looks a bit cleaner and definitely has its place in Python programs. The next shortcut I have for you in Python is the zip function. So I will write it out right here, but it looks like this. What this will do is combine lists or collections together. So usually you can iterate through them at the same time. Now, before I iterate through them, I'll just show you exactly what this does and you'll see why it's useful. I'm going to print the list of the zip of the names, ages, and I_color. Notice how Tim corresponds with 21 and blue, Joe corresponds with 19 and brown, so on and so forth. All of these kind of correspond with each other at the corresponding indexes. If I print this out, notice that we get tuples that are combining all 3 of these things. So Tim, 21 blue, Joe, 19 brown, so on and so forth. That's what the zip function does. Now, of course, I could do this with less things, just names and ages. Now, if I run this, we just get the name and the age. I could, of course, do this with just the names and the I_color like that. And then I just want to show you what happens if you have too many elements in one of your lists. So here, let's just say I add an extra element. So this has 4, this has 4, this has 5. Now I'm trying to zip something that has 4 elements and 5 elements. Watch what happens. Nothing, no error. It simply skips or doesn't consider this last element or extra element in this I_color list. So why is this useful? Well, a lot of times you want to loop through the zip of lists. So rather than looping through them and using the index to access the elements, what you can do instead is something like this. So for, let's go name, age, in, zip, names, ages, And then I could simply do something like, if the age is greater than 20, print the name. And then I get Tim and I get Sally printing out. So that's kind of where this would become useful. Of course, I could add in the I color as well. I would just need to add I_color. Let's change that to colors. And then I could just print the I_color no matter what. So there you go. That is zip. Pretty useful, and yeah, definitely just cleans up the program a little bit. So the next shortcut I have for you is a little bit more advanced, but this is *args and *kwargs. Now, args stands for arguments, positional arguments specifically, and kwargs stands for keyword arguments. Now, positional argument is one in which position matters. So if you look at this, arg1, arg2, arg3, when I call this function, the first value I pass in will be arg1, the second arg2, the third arg3, hence they are positional. The position in which I pass the arguments matters. Whereas if you look at this function right here, these are keyword arguments, which means I could call this function like this, func2, arg2 equals x, whatever. I could do arg1 equals that. I don't even need to pass these arguments, and I can pass them in any order that I want. Whereas up here, I need to pass all of them, and I need to pass them in a specific order. So what is *args and *kwargs? Well, let's say I have a list that has all of the arguments I want to pass to a function, or some collection, maybe a tuple, maybe a string that has all the stuff I want to pass to a function. Well, the way that I can do this is something like this, right? I could go func1, and then I could say args at index 0, and then args at index 1, or I could decompose this, right, or break this down, unpack it, and have, ABC equals args, then pass ABC right here. But there is a much faster way to do this. What I can actually do is write *args. Now, what *args will do is unpack this and split this into all of the 3 individual items. So you can kind of imagine that *args removes this list right here and passes the values 1, 2, 3 like that as positional arguments to this function. So when I go *args, you will see here that I get 1, 2, 3 printing out. Now, obviously, let's just change this, 2, 2, 3. It shows 2, 2, 3. Now, one of the best ways to visualize *args is to do the following. If I print args, notice we get a list. If I print *args, notice I get 2, 2, 3. The reason for that is all 3 of these values are passed as arguments to the print function. So I print 2, then I print 2, then I print 3. So it would look like 2, 2, 3 inside of here when you do *args. Hopefully that's clear, but that's what you can do with positional arguments. Great. Now, when you have keyword arguments, it's a little bit different. So notice what happens here if I pass to func2 kwargs. Okay, so we're looking at func2 and we're looking at our keyword arguments right here. If I do 1 asterisk and I pass kwargs, notice I'm printing out arg2, arg1, and arg3. The reason for that is I am actually passing these as positional arguments, and specifically I am passing the keys in my dictionary as positional arguments to this function. So arg1 is actually equal to the string arg2, arg2 is equal to the string arg1. You can read the output and you can see what they're equal to. That's because we're just passing the keys as positional arguments. However, if I do 2 asterisks, this will actually pass the key as the argument name or parameter name, whatever you want to call it, and then the value as the value for that argument or parameter. So in this case, we'll pass arg2 equals 2, arg1 equals 1, and well, we should get things printing out in the correct order now because we're passing the correct keyword arguments. So to break this down for you as well, what this would look like is arg2 is equal to 2, arg1 is equal to 1, and then arg3 is equal to 3. That's what it looks like when you do *kwargs like that. All right, so a little bit more advanced. That's where I'll leave it, though. Also note that you can do something like *args and let's go here, *kwargs in the parameters, but I'm not going to show that in this video. So the next shortcut I have for you is one that many people do not know about, and this is the for else or while else statement. Now, what this allows you to do is determine if you broke out of a for loop or a while loop without having to use a flag. So let me show you a classic example here. Let's say we have some target value. Let's say this target is equal to 7. Let's say we have some search array or search list, and let's just give it some numbers, okay? 1, 2, 3, 4, 5, 6, and 7. What you'll do oftentimes is you'll look through this search list and you'll try to determine, obviously we need an equal sign here, if the target value is in the search data structure. So in this case, I would do something like for element in search, and then I would check if the element is equal to the target. The element is equal to the target, I found what I'm looking for, so I can break, and then maybe I would print something like I found it, exclamation point, okay? Now, the thing is, I don't know if I got out of this for loop because I broke out of it or because I ran out of elements to look through. So what a lot of people will do is something like this. They will say found is equal to false, and then they can say found is equal to true. And now outside of here, I can check if found, and I can maybe do something like if not found, print I didn't find it, exclamation point, okay? So that's what people will usually do. However, there is a way to actually make this faster. Shortcut, right? What I can do instead is I can simply place an else statement here. Now, what the else statement will do is it will be triggered if we get through the entire for loop without breaking. So in this situation, if I get rid of found here and I run this, notice we get I found it because, well, we found it. The else was not triggered. We broke out of the for loop. However, if I make this target now 8 and I run this, we get I didn't find it because I didn't break out of the for loop. There you go. That's as simple as it is. The else triggers if you don't break out. Otherwise, it doesn't trigger. If you break out, you just escape it. Okay, now you can do the same thing with a while loop. So I will say, while, that's not going to work. We can say while I is less than the len of search, I is equal to 0. Obviously, a for loop is better for this purpose. And I can say element is equal to search at I. And while the same thing is going to work, assuming I increment I, I plus equals 1. I forgot what programming language we're writing in here for a second. Okay, I didn't find it. So same thing works with a for and a while loop. That is all I want to show you, the for else and while else statement. All right, so the next shortcut I have to show you is called sort by key, and it is going to be relatable for you if you are trying to sort something that is relatively advanced, or your sorting criteria, is not default, like you're not sorting in ascending or descending order. What you're sorting by is something unique that the built-in Python function just doesn't do. So let me show you. If I were to sort this list, so lst.sort, this will sort the list in place, and I print lst, what do you think is going to sort it by? Well, it sorts it by the first element inside of the nested list. That makes sense. That's intuitive. So we get -1, 1, 2, 3, 4, and 4. However, what if I want to sort by the second element in the list? Well, there's not really a way to do that. I mean, I could sort this in reverse. I could say reversed equals true. And now if I do this, reverse equals true maybe. It gives it to me in the reverse order. However, again, I want to sort by this second element. So I could write my own custom function that sorts this, but instead, there's actually a way you can do this using the built-in sort method. What you do is you pass an argument to this called key. Now, key tells you what it should sort each element inside of the list by. So every element inside of the list is one of these nested lists. So what you need to do here is pass a function that returns what it should sort by for each element. So in this case, I'm going to say key equals lambda x colon x1. Now, what is lambda? Lambda is a one-line anonymous function. I'm not really going to explain it too much, but essentially x is our parameter for this function, and what I'm returning is x1. x1 is going to give me the second element inside of the nested list. So if I do this now, it's going to sort by the second key, or sorry, second element. So we get 2, 2, 3, 3, 4, 5. There you go. That's as easy as it is. Now you can make this more advanced if you want. I could sort it by x1 plus x0, and now it will sort it by the sum of the values in this list. So if I do this here, we get this is the lowest, then 3, then 5, then 6, then 7, and then 9. Makes sense. Now, in case the lambda is confusing any of you, it's the exact same as doing this. So I can define, let's say, sort underscore function. This is going to take in x, and I'm going to return x0 plus x1. Now, instead of passing the lambda, what I would do is pass the sort underscore function. It's going to then return x0 plus x1, and then it will sort based on this key that we've put here. So this will give us the exact same thing. Hopefully that makes sense, but a useful feature. This works not only inside of the dot sort, it works inside of the sorted as well. I can pass LST and then key equals, and anything that sorts in Python, you can usually pass this key parameter. All right, so that was all of the shortcuts that I wanted to show you, but if you stuck around until this point, I'm going to give you a bonus shortcut. This is called itertools. Now, itertools is a very cool module in Python that allows you to do iteration-related operations and can save you a ton of time. A lot of stuff you normally do manually, you can probably just take right from itertools. I'm just going to give you a few very short examples here of what itertools can do, and then, of course, you can look up the documentation on your own. So first, there's this function from itertools called accumulate. What this will do is accumulate the sums of the values in order or in sequence from this list. I probably misdescribed that, but just have a look at what we get here. When I do this, notice I get the sum of the first element, which is 1, then the sum of the first and the second element, which is 3, then the sum of the first 3 elements, which is 6, then the first 4, which is 10, and then finally 15. That is accumulate from itertools. The next thing I'm going to show you is called chain. So let's have a look at this. Pretty straightforward, but what chain will do is combine the 2 lists that you have into one list without actually creating a new list such that you can iterate through it. So all of these itertools related stuff, they usually return to you an iterator. Now, if you're not familiar with the difference between an iterator and a data structure, an iterator is something that allows you to iterate through something. It doesn't necessarily create a data structure. So in this case, when I chain 2 lists together, I'm chaining list 1 and list 2, this returns an iterator that I can loop through that doesn't necessarily create a new data structure that has list and list 2 together. The reason that's important is because if you were to create that data structure using up more memory in your program, more space in RAM, so rather than actually creating it, which you and I would usually do if we want to loop through both of these and have them kind of combined together, you can just use .chain and, well, it just works. Hopefully that was a decent explanation, but let me run this and show you. So when I chain this, I get 1, 2, 3, 4, 5, A, B, C, D. Now in this case, since I converted this iterator to a list, it did create a list, but you could loop through this in a for loop and it wouldn't actually create the data structure for you. It would use the 2 existing data structures and loop through them in the correct order. Okay, that is the chain. Now, the last one I will show you here is called compress. What compress will do is it will only give you the values that correspond with a true condition in another list. A little bit confusing, but look here, I'm compressing names and show. Names is a list of names, strings, show is some Boolean values. So 1 is true, 0 is false, okay? If this, in this case here, when I run this and you look at this, I get Tim, Bill, Jen. Notice Tim corresponds with 1, Bill corresponds with 1, Jen corresponds with 1. It doesn't give me Joe and it doesn't give me Susan because here we have 0. So that's a false, right? This is, imagine these are just true and false. That's what compress does. Again, doesn't necessarily create the data structure for you, allows you to iterate through it, but since we're converting it to a list so we can see what it's actually returning, in this case, it does create the structure. All right, I don't want to get into those in too much detail, just wanted to introduce this to you in case any of you have not seen it. I may actually be making a tutorial on it in the future, but with that said, I'm going to end the video here. I tried to go pretty fast so that I didn't waste any of your time. If you guys enjoyed the video, make sure you leave a like, subscribe to the channel, and I will see you in another one.